All right, this next section deals with nth roots. And an nth root looks like the following. An nth root can be illustrated as the nth root of some power or some value. Okay, the nth roots are the roots that you're familiar with. You're familiar with a square root. Okay, a square root, you're familiar probably with a cube root. Okay, what an nth root does is an nth root identifies what value can you multiply by itself n number of times to give you the value that's inside your radical. So let me talk about some terminology that I'm going to use to describe these. Okay, the nth root itself is called an index. Okay, so the index is the nth root. It's the number of times something needs to be multiplied by itself to give you the base on the inside. Okay, so the number on the inside will have two parts potentially. It has a base. If it's just a number, I'll refer to it as a base. And then it may have a power as well. And so an nth root just means or an nth root identifies the number that has to be multiplied by itself n times to equal the base. And now, if it's a base with a power, and that would be part of it as well. And so when you're looking at these kind of more common nth roots that you've used before, the nth or the square root of 4. Oops, and let me go through one last thing. In a square root, the index is an unwritten 2. Right, so when you're looking at a square root of 4, the square root of 4 tries to identify what number has to be multiplied by itself n times. Again, this is an unwritten 2, so twice, to give you the value inside your radical, 4. So what number multiplied by itself twice is equal to, or multiplied by itself is equal to 4? And the answer is 2. Okay, for the cube root of 27, it's asking what number can be multiplied by itself this many times to equal this number on the inside. So what number times itself 3 times is equal to 27? And the answer is 3 times 3 times 3. And so the answer happens to be 3 here. Okay. So you're finding the value that can be multiplied by itself n times to equal the whole base that's inside. All right, so there's a couple ways that you're going to see problems like this. Here's one way that they'll direct you. And so find the indicated nth root of A, and they'll give you several to choose from. So just take a moment, see if you can answer these 3 questions. All right, in working through these, if you were to look and take your nth root, so cube root of -1, what number can be multiplied by itself 3 times to give a value of -1? It's negative 1, right? So that would be the cube root of negative 1. How about the next one? The nth root, so fourth root of negative 16. Is there any number that can be multiplied by itself 4 times to give you a negative 16? Does this work? Here, all the negatives, you have 4 negatives, so they're going to cancel. Those 2 cancel, these 2 cancels. So you have 16. Is 16 equivalent to negative 16? No. So this one is not possible. And in fact, you can never take an even indexed radical. So you can't take a square root or a fourth root or a sixth root or any even index of a negative number in the real number system. And then finally, you have the square root. So again, an index of 2 is unwritten in the square root of 49. So what number can be multiplied by itself to give you 49? 7. Okay. So that's what you're looking for when you're simplifying in that form.